Hello and welcome to the next video in my pre-algebra review series. Today's video covers Chapter 4, Section 8 of your textbook, entitled Exponents and Division. By the end of this video, you should have a better understanding of dividing expressions containing exponents and simplifying expressions with integer exponents. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them and certainly help this channel get seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to get notified every time I release a new video. Thank you. Objective 1. Dividing expressions containing exponents. In Lesson 4-7, you learned that you add exponents when multiplying powers with the same base. To divide powers with the same base, you subtract the exponents. Here's why. Let's look at the example here. 7 to the 8th power divided by 7 cubed. If we expand the sevens, we see that we have 8 sevens on the top of this fraction, and we have 3 sevens on the bottom. Well, if we divide out the common factors, and the common factors are the sevens in red, I've highlighted them here. So there's 3 red sevens on the bottom, 3 red sevens on the top. So they match each other 1 to 1, so you can cross them off. And what remains then are 5 sevens. So we see the answer then is 7 to the 5th power. So you notice here that 7 to the 8th divided by 7 to the 3rd is equal to 7 to the 8 minus 3 power, which is equal to 7 to the 5th power. This kind of suggests the following rule: dividing powers with the same base. To divide numbers or variables with the same non-zero base, subtract the exponents. Arithmetically, you would see 4 to the 5th divided by 4 squared is equal to 4 to the 5 minus 2 is equal to 4 to the 3rd power, or 4 cubed. Algebraically, we would say a to the m divided by a to the n is equal to a to the m minus n. That's for every a that's non-zero a, that is, because you can't divide by 0, so the a can never be 0 in this case. This is for positive integers m and n. Example 1, dividing a power by a power. Let's simplify each of these expressions. For a, we have 3 to the 8th power divided by 3 to the 5th power. And based on what we said in the previous slide, if we're dividing powers, we take the numerator and subtract the denominator. So 3 to the 8 minus 5. And when you complete that mathematics, you find out it's 3 cubed, because 8 minus 5 is 3. And then to simplify it, as it requests here, 3 cubed is 27. As for b, we have a to the 4th power raised over a squared. Well, in this case, we take a divided by a to the 4th divided by a squared is equal to a to the 4 minus 2. If we complete the math on that exponent, we have a squared. Then you can't do any more with it. We seem to be done at this point. For example 1, under check your understanding, they want us to simplify each of these 3 expressions. So let's try it. So let's simplify it. 10 to the 7th divided by 10 to the 4th. So what does that end up being? We'll say 10 to the 7 minus 4 is equal to 10 to the 3rd power. 10 to the 3rd power is what? Does anybody know? It's equal to 1,000. 10 times 10 times 10. How about b over here? We have x to the 25th power divided by x to the 18th power. Seems really complex, but what it really amounts to is x to the 25 minus 18, and we'll put a parenthesis on here, And that equals what? 5 and 3, or 2 rather, is 7. So it's x to the 7th power. And let's go here to C. We have 12 m to the 5th divided by 3m. So we're going to do this. We're going to say 12 divided by 3, because we don't need to try to subtract exponents or anything. 12 divided by 3 is 4. Okay, and then we have 5 m's on the top and 1 m on the bottom, so it's 5 minus 1. So times m times 5 minus 1 is equal to 4m to the 4th power. Okay? On our next slide here, it asks the question, what happens when you divide powers with the same base and get 0 as an exponent? So consider 3 to the 4th divided by 3 to the 4th. That's one thing to think about. And then also remember that 3 divided by 3 is equal to 1. Okay, so let's run this down a little bit. So 3 to the 4th divided by 3 to the 4th is equal to 3 times 3 times 3 times 3 divided by 3 times 3 times 3 times 3. And we'll expand this out because all of these can be, in commutative property of multiplication, we can expand these out in little groups. So we can say 3 divided by 3, 3 divided by 3, times 3 divided by 3, times 3 divided by 3, times 3 divided by 3 is equal to 1 times 1 times 1 times 1. And we all know that 1 times 1 times 1 times 1 is equal to 1. That's our final answer, 1. So in this case, 3 to the 4th over 3 to the 4th, the answer is 1. So a concept to think about here is 0 as an exponent. Arithmetically, 3 to the 0, right here, 3 to the 0 power is equal to 1. And a to the 0 is equal to 1, for a not equal to 0, because you can't have the 0 raised to a power. Okay, so what happens if you divide powers with the same base and get a negative exponent? A little bit different. Consider 3 squared, over here, 3 squared divided by 3 to the 4th power. So in their example, we're going to do just what we did mathematically from above. So 3 squared divided by 3 to the 4th is equal to 3 to the 2 minus 4. And that equals to 3 minus 2. Oh, so now we've got a negative exponent. So how do we deal with that? Well, let's expand it, and we can better see how you take care of it. So 3 squared over 3 to the 4th is equal to 3 times 3 over 3 times 3 times 3 times 3. 2 3's on the top, 4 3's on the bottom. So if we cancel out what's common here, so we have a set of 3's up here, and we have 2 3's down here. When we cancel these out, they become 1. And because that's, why is it 1? Because 3 over 3 times 3 over 3, that's these guys canceling. And then times 1 over 3 times 1 over 3, because you don't have any other 3's on the top to offset them with. So that means 1 times 1 times 1 over 3 times 1 over 3. And that equals 1 over 3 squared. 1 over 3 squared. So what did that just tell us? What did we learn from that then? So a negative exponent, right here, a negative exponent leads to driving the exponent to the denominator. If it's in the numerator like it is here, it drives it to the denominator. So it's 1 over 3 squared, but we lose the negative sign. So now it's positive. If it was the other way around, it's a little more complicated. But if it was 1 over 3 to the minus 2, you can do just the opposite. You can take that and bring it up to 3 squared over 1, if you want, on the top. So that's kind of something else that you can think about. Simplifying when 0 is an exponent. So this is kind of what we just went over, but we're going to get a little more practice with it. So we're going to start off by looking at minus 8, the quantity. The parentheses makes you say the quantity. Minus 8 squared divided by the quantity minus 8 squared. Well, that equals the quantity minus 8 to the 2 minus 2, right here, the 2 minus 2 power right there, from these two powers. 2 minus 2. And then 2 minus 2 is 0, so you get the quantity minus 8 to the 0 power. And as we said in the other slide, anything to the 0th power is equal to 1. And here in this example, we have 6b cubed over 18b cubed. Well, if we take and expand these out using the commutative law, we can move these around. 6 divided by 18 is 1 over 3, 1/3. And the b cubed minus over b cubed is equal to b0, because it's b to the 3 minus 3. And so we end up with 1/3 times 1, because this right here, b to the 0, ends up being 1. It's equal to 1. So we end up with 1/3 times 1, and the answer is then 1/3. Okay, let's check our understanding. What we're going to do here is we have 4 problems, and we're just going to simplify them. So in the first problem, we have what? We have a 43 raised to the 0 power. So what's the answer to that? It's pretty straightforward, because we said from just the earlier slide, it said anything to the 0 power is equal to 1. So 43 to the 0 power is equal to 1. How about over here on B? We have b, 5 squared x to the 6th divided by 5x to the 6th. Well, what are we going to do? We're going to say, I'm just going to write it out. We're going to say 5 to the 2 minus 1, because any number with an exponent like that is to the first power. And then it's times x to the 6 minus 6. So that ends up being 5 to the first power times x to the 0th power times x to the 0th power is equal to 5 times 1. The answer ends up being 5. 5 is the answer. How about this one? X to the 5th, y to the 6th divided by x to the 5th, y to the 3rd, or y cubed. Well, we know that we have equals x to the 5 minus 5 times y to the 6 minus 3. And that equals x to the 0 power, times y to the 3rd power is equal to 1 times y cubed is equal to y cubed. There's our answer. Now, right off the bat, 5 to the x to the 0 power, they're kind of doing our work for us. It's 5 times 1 is equal to 5. There's the solution to that one. So example 3 is pretty much like example 2. We're going to solve these and simplify them, or we're going to see how they do it here in this case. But what's different here is that there's going to be a negative exponent, and it's going to raise or drop us above or below the line, and we'll see how it works. For A, we have 5 to the 6th divided by 5 to the 8th. So 5 to the 6th divided by 5 to the 8th is equal to 5 to the 6 minus 8. And that's going to leave us 5 to the negative 2. Okay, and 5 to the negative 2, like we said before, that's 5 squared on the bottom, because we're going to move it to the bottom. So it's 1 over 5 squared. The negative sign here goes away. So this was above the denominator. Now it is the denominator. And if you solve it out, 1 over 5 squared is equal to 1 over 25. And over here on this side, you have, for b, you have m squared divided by m to the 5th, which is m to the 2 minus, right here, m to the 2 minus 5. And it gives us an m to the minus 3. And that means that you're going to move it, since this is above this is the numerator, there is no denominator. The denominator here is 1. Sorry about that. The denominator is 1. So we're going to move this to the denominator. It means the negative sign is going to disappear. So it's going to end up being 1 over m cubed. So here's our answer right here. So in example 3 of Check Your Understanding, they'd like us to simplify each expression. So we have 3 expressions here. Starting with A, we have 4 to the 5th power divided by 4 to the 7th power. So we have 4 to the 5th divided by 4 to the 7th, which equals 4 to the 5 minus 7, which equals to 4 to the minus 2 power. Well, 4 to the minus 2 power, we're going to write that exponent into the denominator. So we're going to have 1 over 4 squared. And what does 4 squared equal? It's 4 times 4 is 16. So the answer is 1 over 16. Here's the answer for this one. For B, we have a to the 4th minus 6. So a to the 4 minus the 6. So it's a to the 4 minus 6. And that equals a to the minus 2. We got another squared going on here. This time we're going to move the a to the minus 2 to the denominator. So it's going to be a to the, 1 over a squared. There's our solution for this one. And then finally over here in C, we have 3y to the 8th divided by 9y to the 12th, which is equal with writing it without a denominator. We'll bring this up to the top. First of all, we're going to start by 3 over 9 is equal to 1/3. And then on top, we're going to have y to the 8th minus 12 times y to the 8 minus 12. 8 minus 12. And I'll put parentheses here, parentheses. So that equals 1/3 times y to the minus 4. And taking the negative exponent to the denominator, you end up with 1 over 3y to the 4th power. Okay, that's it for that. So here's a different little spin on what we're going to do with the exponents. What they want us to do is write this equation, or this fraction here, x squared y to the 3rd power over x cubed y. They want us to write that without the fraction bar. So that kind of means that that's telling us that whatever's on the bottom, they want us to put it on the top, because there'll be no fraction bar. It'll be over 1 when we're all done, and that 1 is given, so you don't have to worry about ever writing it. It's because all numbers are the number over 1. It's still kind of a fraction, but it's a special one. But in our case, they want us to move the denominator up to the numerator. So what are they doing here? So they're showing us the expression. They say that this is equal to x to the 2 minus 3, because that's why we have 2 minus 3, and y to the 3 on the top over here, right there, the 3, to the 3 minus 1. So when we do that, when we carry out the mathematics here, we have x to the minus 1 y squared. So what we're going to do here is we're going to move this x by itself to the bottom. That's kind of simply what they're showing. They didn't show us that we're removed without the fraction bar, but I guess the whole problem is right here is without a fraction bar. But so let's go to the next problem, see what they want on that one. And now in example 4, for check your understanding, we're going to write each expression without a fraction bar. So they don't want us to put it in the form where there are no negatives. So if we end up, when we get done doing it, if there's a negative in the numerator or denominator, we're going to leave it there. There will not be a fraction bar, so actually there won't be a denominator. There'll only be a numerator, so to speak. So let's try this. We have b to the 3 divided by b to the 9, and that's equal to b to the 3 minus 9 is equal to b to the minus 6. That's the answer. If we were going to complete it with a fraction bar, we'd move this b to the minus 6 to the denominator, and it would be to the 1 over b to the 6th. Let's go to b, over here to this problem b. We have m cubed n squared over m to the 6th n to the 8th. So what does that equal to? The m's, keeping them together, we're going to have m to the 3 minus 6, and we're going to have n to the 2, or n squared, minus 8, and that's going to equal to m to the minus 3 times n to the minus 6. There's our solution. If we were putting a fraction bar in here, both of those would go to the denominator. It would be 1 over m cubed times n to the 6th power. Let's do this one. So we have x times y to the 5th power divided by x to the 5th power y cubed. Same as before, that is equal to x, bringing the x's together, x to the 1 minus 5. That's that exponent, because x here is to x to the 1, and it's times y to the 5 minus 3. So this is going to resolve out to be an x to the minus 4 times y to the 5 minus 3 is 2 at y squared. In this case, if we brought this to the bottom, we would have y squared over x to the 4th, but they want us to leave it without a fraction bar. There's the answer. Okay.